Hi, good morning, and welcome you all to the CloudSiksha Academy webinar. I'm glad that you could all join on a Sunday morning. Today, we will do the AWS Certification webinar, and it will be on S3 and Glacier. I will now share the slides with you, and we will take on the webinar from there. Give me a second and I will have the slides up and running for you. Here we go. So today's webinar, as I told you, is on S3 and Glacier. And I've told this earlier, and I say this again, that this webinar does not intend to explain every service. Basically, it's assumed that you know about the service. We will talk about some of the important points of each of the services. And there are probable questions that may come up in the exam, and we will discuss that. And if you really want to learn about AWS and from scratch, you can always visit CloudSiksha Academy. You will find the link available as academy.cloudsiksha.com. So today's session is going to be on S3, and we will be seeing what is S3 and how this is used. S3, as the name indicates here, is called as a simple storage service. This was one of the earliest service that Amazon had introduced. The first one was SQS and the next one was S3. It's an object-based service, and objects are stored in buckets in S3. And buckets have to have a unique name across all AWS regions. That's a basic thing about S3. That is, it's a place where you can store your files. So, or in other words, a classic cloud storage. Now, we come to what is known as S3 storage classes. When you store your object, you can store in 3 different classes. There's also another class which is Glacier. We'll discuss that later. There's 3 classes: S3 standard class, S3 infrequent access class, and reduced redundancy class. These differ in terms of the durability and their availability. If you take S3 standard class, you get about 11 nines durability, and it is designed for 4 nines availability. Actual SLA they sign up will be 3 nines. And an infrequent access class, 11 nines durability exists, and this is 3 nines availability. I made a mistake in the slide here. It's 3 nines availability, and they will sign an SLA for 2 nines. The reduced redundancy storage has 4 nines durability and 4 nines availability. Now, these are important for you to know. As you can see, the most safe storage and storage which can be accessed at any point in time would be the standard storage, because it has a 4 nines availability and 11 nines durability. Suppose you are not accessing files often enough, then you can use infrequent access class. whenever the files have to be accessed only once in a while. And if there are files which can be regenerated, now that could go into reduced redundancy storage. The reason they have these three storage options is depending on what is the importance of the file to you, you can choose one of them. And the cost differs. So S3 standard is the costliest one. Infrequent access is slightly cheaper than S3. Standard and reduced redundancy is the cheapest of these three. So generally in the exams, you get some questions in terms of the cost aspect. So they may ask you, I have this storage, which storage class should I store? Or they would say, how do you optimize the storage? So in which case, you have to look at the importance of storage to the organization. If it's a very important document and which needs to be accessed fast, then of course you go for something like the standard storage. But if you think they mention that, this storage needs to be accessed, but once in a while, like once in 3 months, I take it out to prepare a report, then you can look at going into infrequent access class. Or if there are other things, right, that is where you can generate them again. For example, you have an important video which you don't want to delete, but you made a small clipping of that video. Now that clipping of the video you can regenerate again. So that clipping you don't need to store in standard class, you can go ahead and store it in reduced redundancy class. That will make it cheaper, and even if you lose it, because it's only 4 lines durability, even if that is lost, you can regenerate that. Or if you have pictures, there are thumbnails of the pictures that you can store here. Or if you generate a report out from a certain files, the core files could be in standard class and the generated report could be in reduced redundancy storage. So there are two things. One, if you have a file which you can afford to lose, you can store there, or files which can be regenerated, you can store there. So understand this, because this is going to come both in terms of where you store important files and where you store less important file, and the association with cost. So your questions are always going to be something about cost and how you will manage cost in S3. Then this becomes an important aspect to manage your cost. Now when it comes to S3, you have S3 objects. In S3 objects, there is no limit to the number of objects that you can store. Now every account is given something like 100 buckets, but if you need more, they will give you more. It is a soft limit. But from an object perspective, there is no limit to the number of objects that you want to store, that you can store. This is another important thing. So if a question comes up saying, I don't know how much storage I would need a lot of storage, but don't know how much it is and all, then you can always think of S3 as an option, because there is no limit and you don't need to commit right in the beginning as to how much storage you want. The minimum size of an object that you can store is 0 bytes. The maximum size per object would be 5 terabytes. And every put operation, that is every operation that puts an object onto S3, cannot put more than 5 GB. So if you want to put more than 5 GB file and you want to do it effectively, then you use something known as multi-part upload, where the file is split into multiple parts and they're uploaded in parallel and then combined together later. S3 also gives you multi-object delete. So if you want to delete multiple objects at the same time, you can do that. The multi-part upload, you may get some questions on that. If there's a bigger file, what to do? You can use multi-part upload to ensure the byte. Now from the point of view of regions, whenever you create an S3 bucket, it is created in a particular region. You have to select the region. Therefore, S3 is a region-specific service. So you have S3 bucket in one region. Of course, you can access that bucket from anywhere, but when you create, you have to specify the region. So why do you require it in a particular region will depend on your own considerations. Like if the bucket is in Mumbai, then from India, whoever is accessing it could access it faster, and so on. There are times when you may need a bucket in two regions with the same data. I mean, the same bucket in two regions. It could be one for disaster recovery purposes. You may say that my company is very, very particular about disaster recovery, and therefore I cannot just depend on one S3 bucket. What happens if the complete region of AWS goes down? So in that case, you may want the bucket replicated to a different region, or you may also want to replicate because of performance issues. So let us say you have two teams which have to access the same files, but each in a different place, one in Mumbai, one in Oregon. Then in that case, you have this problem that people, if you have the bucket in Mumbai, the people accessing it from Oregon may find that the latency is very high. So in that case, you would want a bucket in both these regions, but the bucket should have identical data. In other words, all the objects need to be replicated. So for this, the cross-region replication is supported by S3. So whenever you're talking about disaster recovery or any such thing, you look at cross-region replication. If such a question comes up in the exam, look up for cross-region replication. The other question that generally appears in the exam is about consistency model. What do you mean by consistency model? It means that once you put an object, for everybody is the object that they are fetching the same. You may believe that why should there be or you may think that why is there a difference? Everybody should get the same object. Or if after I delete an object, if I fetch the object again, would I get the object? Again, you may think that it's obviously not. But in distributed systems like S3, where there are multiple copies of the object kept for sake of redundancy, because they are giving you 11 nines durability, so they copy your object redundantly, that the object is available in multiple places. So when you delete an object, the way they respond to you, if they want to respond to you fast, you may be told that the object is deleted after it gets deleted in one place, but they do a lazy delete over the other places. So a small window exists where after delete, if somebody were to get the object, they would still get the object because not all the copies have been deleted. I'm just giving you a very high level view of this distributed systems. There are a lot of theory on distributed systems. We'll not go into that, but remember this. So since S3 is a sort of a distributed system where they are copying your file to multiple places, you get into the situation of having what is called as eventual consistency. Eventual consistency basically means that you will achieve consistency, but probably there will be a short duration of time where the system is what we can call inconsistent. So it is not going to be absolutely consistent immediately. So on which conditions are not going to be absolutely consistent or immediately consistent? That is going to be in the case of an overwrite put. So you have an object, you overwrite an object, or you delete an object. In these two cases, there is no what is called as read after write consistency. So even after I delete it, there is a small time window where there's a possibility if somebody were to get the object could be got. So the eventual consistency for put and delete is what S3 assures you, and read after write consistency for put for new objects. So if it's a new object that you are uploading into S3, only after that object has been written to all places will you be getting back an answer saying that yes, your object has been uploaded. So that way, immediately if somebody reads, they are bound to get that object. If it was not read after write consistency, what could happen is, even after you put an object, somebody tries to read it, they may get an answer saying the object is not available. That doesn't happen because we have read after write consistency for put of new objects. So whenever you load a new object, you can be sure that once they say the object is loaded, anybody tries to get the object, they would definitely get the object. Whereas that's not the case in override, put and delete, which are eventually consistent. So this question may appear in the exam about consistency model. Keep this in mind. The other questions that generally come up have something to do with the security of S3. Obviously, you are storing a lot of files and many of them are important files. So how do you ensure security for them? So what help does S3 give you? And from an exam point of view, some things that you get are the access control mechanisms that they have. Bucket policies is one access control mechanism. So you can have a bucket and put up a what you call a policy on the bucket, where you say that this bucket can be accessed only by this user and no one else, etc. And you can also have more fine-grained control using access control list. So access control list can go to an object level and say this object can be accessed by somebody, not by somebody else, and so on. So you have both these things, a policy at the bucket level and ACLs which can work at the object level. Then you can do encryption. I'll talk about encryption soon. Another thing is you can deliver private content using a pre-signed URL. Basically, if you make your bucket public, anybody can access it. But if you make it private, nobody can access it except you as a user. So what if I want only a limited set of people to access my bucket? So you can send them what is called as a pre-signed URL, keep your bucket private, and you sign a URL and send it to them, and that pre-signed URL would have an expiry time associated with it. So the pre-signed URL, expiry time together will ensure that there is a decent amount of security for you. So only those with a pre-signed URL will be able to access your bucket. Those who come from a normal URL will not be able to access your bucket. As you know, every object is a URL. So if they don't have the pre-signed URL, they cannot access the object. And combined with CloudFront, this becomes even more secure. In CloudFront, you can have something known as origin access identity and ensure that people come only through CloudFront using a pre-signed URL, and only CloudFront can access S3. You can put that also. So you may here in the exam, you may see terms like OAI. OAI is origin access identity. So origin access identity combined with pre-signed URL is one method of keeping your objects secure. So if you see that OAI and if you see pre-signed URL in a question as in an answer to a question, you know what it is now. S3 also allows you to log in all access for a bucket. So you can turn on login. So when in bucket properties, you can turn on login. So you know who has accessed that bucket, when the person has accessed and all, and the log files are stored in the bucket, in the same bucket or other bucket. You can configure that. And the log files are stored and you can look at the log. So if there is a need for compliance and show people that no unwanted activity happened, you can show them the logs which get stored. I told you I'll talk about encryption. Now, when you store your object into S3, you can ask S3 to encrypt it. And this encryption can be done at two ends. That is, one, you can upload an object, and before S3 stores it, it can encrypt that object and store it. If you want to ensure that even your data in flight is encrypted, then you can do client-side encryption, that you encrypt on your end, at your end, and then only store the encrypted object. So when it comes to S3 itself doing the encryption, there are three methods of doing it. Now, S3 will have its own encryption keys and use the encryption keys of its own, and it does AES 256 encryption if it uses its own keys and stores your objects in an encrypted form. So whenever you need an object back, it will decrypt using its own key and give you the object. Suppose you don't want S3 to use its own key, then you have two options. One, either you can use the Amazon service called KMS, the key management service, and keep your keys there, or generate your keys in KMS and give that key to S3 and tell, please use this key from KMS to encrypt my data. Now, if you don't want to use KMS and you have your own keys, that's what we have written here as SSE. Okay, SSE here stands for server-side encryption. So note that down, because in an exam, many a times they may ask you about SSE. The answer could be, what would you do? Which are the valid types encryption? So they may say SSE, S3 or SSEC. Then that means server-side encryption. S3 means server-side encryption using S3 keys. SSEC means server-side encryption using client keys. So you have your keys in your own infrastructure, in your own say data center, and you provide the keys to S3, and S3 will use the keys. Now, keeping the key safe is your problem. It's your responsibility. Whereas in the case of S3 keys and KMS, Amazon takes care of the keys, keeping the keys safe for you. As I said earlier, you can also do client-side encryption. So encryption is a very important aspect of security, and there are multiple ways in which you can do the S3 security. Then comes the issue of data corruption and about versioning. S3 uses checksums to continuously check your data at rest. Now, if it finds that there is a problem, it automatically corrects the problem because it has multiple copies of the same object. Remember that it has copies of the same object. If it can be error corrected, it does error correction. If there is a need, it can always go and check the other objects which are not corrupted and then accordingly make the error correction. And it also does checksums of the network data. Before it stores anything, it also does a checksum of that data to ensure that you have minimal data corruption. Another question that often turns up in the exam is about how do you ensure that accidental delete of object does not happen. The standard answer you will see in multiple places is that you turn on versioning, and you can also turn on what is known as an MFA delete, multi-factor delete. Now, this multi-factor delete will ensure that you need one more authorization, two times authorization to do the delete. Then versioning a bucket, you can turn on version. You cannot turn off the version. You can disable versioning later on if you want. You can't say turn off, it's just disabled. When you version a bucket, the thing is that whenever you load an object, the old version of the object is anywhere stored. The new version is also present. Though depending on how you see the screen, you will see either only the new version or you will see new version plus old versions. Both the options are available on the screen to hide the versions and not hide different versions. So in versions case, the idea is that it is just like any version control thing that you see, in the sense that whenever you write a new file, the old file is still there. The new file doesn't overwrite that. There's a new file, there's an old file. Similarly, when you delete file, the file does not go away. That's why we say that we can prevent accidental deletion, because when you delete, the file doesn't go away. You can it just gets hidden. You can go back and fetch the file again if you believe that it was a mistake to delete that file. Another important question that comes up is about life cycle. So this is very this is something that you must know, and it's something that I think I always have seen this turning up at various exams. Life cycle means moving objects from one storage to another, or deleting an object. Basically, depending on the importance of the object, you want to move the objects across, basically to ensure you do good data management in one hand, and secondly, good cost control in the other hand. Because if you keep all objects in the standard storage, it's going to be very costly for you. So what you can do is, as the objects get older, they may not be accessed often. You can shift those objects to standard infrequent access class. Then later, you believe there's no more a need to access objects very immediately. So you can then move that on to Glacier. The Glacier is an archival solution. We'll talk about it. That, of course, gives the cheapest cost. So this can be done in an automated way. So that's why we say this is a life cycle, because the life cycle of an object is from the time it's created, from the time it's deleted. How do you want to handle it? This can be done automatically. So you can go to a bucket and set a life cycle either to the bucket or to a folder inside a bucket, and say that any object in this bucket which is older than 60 days, for example, move it to infrequent access, and after it stays in infrequent access for 3 months, move it into Glacier. And then what do? You either keep it in Glacier for its lifetime throughout without any deletion, or you set an expiry date and say that, okay, these are finance records I'm supposed to keep for 7 years, and I say that this should be in Glacier for 7 years. Now you don't need to worry, after 7 years it will automatically get deleted. All this movement will happen automatically. So the questions that appear in the exam will be regarding this. They'll say, I have an object, or I have a file, and after 30 days the file is not accessed so often, and then after 6 months I don't need the file. How would you optimize this cost? So in such cases, your answer would be that it goes to infrequent access, and then it goes to directly to expiry. You don't need to move it into Glacier. So these sort of things you need to keep in mind. That the questions will be around cost management, how you would do cost management based on life cycle. So it will come out in the cost section rather than the S3 section, I would say. So it will say that if this is my requirement, how do I optimize the cost? And then you have to see how you set up the life cycle to optimize this cost. There are some other tips which is there. You have S3 which S3 supports events. That means whenever you upload a file into S3, whenever you delete a file in S3, you can generate an event. This is more important from the developer's perspective, where events are very important and they form the backbone of doing an event-driven programming. So this S3 supports events. Now, the way S3 stores is such that if you can name your files randomly, especially the first few letters are random, then the storage efficiency is better in terms of how you can fetch it and how you can write it. Because if the naming is the same, if you, for example, start with the same name, we have this thing, right? You may say the finance files all start with name as finance, then they may all, because of the first few letters, they may all be stored in the same place. So when you want to fetch, they will have to go and look at it one after the other. But if the name is random, they get stored at multiple places based on the text that comes up. So if there is a question in the exam about efficiency and how to store, the thing to remember is they may, for example, give you a question where they say that I have files. I want to store it as year, month, date, and then the file name. Or I want to store it as month, year, date, the file name. Or I want to store it as date, month, and time. So, or if it says time, day, and all. So, time will be the one which is changing very fast. So, every file, suppose you take year, you may end up everything being 2018 in the beginning, and it won't be as efficient in writing and reading that file, set of files, when compared to doing the random thing. So you may say that a file gets stored based on the time as a timestamp as the first one, then it becomes much random. So the first file may be stored at time X, the next file, the time would change, and therefore you get certain randomness in it. So whenever you're talking about efficiencies, look for randomness in the first few letters. And so if you're given options, choose the one which is the most random of this. The other thing is that sometimes they may say, I have a website, and how do I set up this 3-tier website, 3-tier application with a web application, etc., etc. Or they may just say that as a part of this, we are doing a standard static website. Then if they are talking about cost optimizations in that way, you can say that a static website can be hosted by S3 bucket. So you don't need to pay for any service provider to host your website. You just have a bucket and just put up an index file and turn on the static website feature of the bucket, and your static website will be hosted there. You don't need to actually take an EC2 instance or go to any hosting provider to host the website. It can directly work out of S3, and that will be much cheaper for you. The other thing is, when you want to upload a file, there is something called transfer acceleration which is supported. Basically, transfer acceleration will use the root of CDN to upload your file to S3 faster. What they promise you is, if they are not able to upload it faster than a normal route, so the normal route for you would be to go through the internet. There they go till the CDN, and from the CDN they reach their internal S3. So if that route happens to be faster, they will charge you. If that route doesn't happen to be faster, they won't charge you. So that's called as transfer acceleration. Next, we will go to Glacier. Glacier is for archival storage, as I told you earlier. It is for storing files long term, and for files which are not, we generally don't want to download. So we want to just store and forget for most part of the time. Okay, so how do you move to Glacier? Basically, you use a life cycle in S3 and move these to Glacier. So, and you retrieve this back using an S3 API. So you make a S3 API call or from S3 console, you retrieve this file. What happens is when the file is retrieved, it will put that file into RRS for a certain amount of time, which you can specify, and then you can download that file. The file class will be RRS. Sorry, no, I wouldn't say the class is RRS. They put it in RRS storage, but that doesn't mean that the file from Glacier is gone. It is still there. They're just putting a copy onto RRS. You can get it down from RRS. Now, unlike S3, where all S3 or infrequent access, standard, and RRS provide you the same download speed. There's no difference in the download speed in any of the three. In case of retrieval for Glacier, there is a difference. So in Glacier, they give you 3 levels of retrieval. One is called as an expedited retrieval. The expedited retrieval basically gets you back an object within 1 to 5 minutes. The standard retrieval gets it back in 3 to 5 hours, and a bulk retrieval will get in 5 to 12 hours. Of course, the faster the retrieval, the more costly it is. The slower the retrieval, the cheaper it is. So in Glacier, that's the idea. So Glacier basically is an archival system which helps you store files for archive and costs very low. They claim that the cost is the same like storing on a tape. And finally, they've added a lot of new features. Query in place, Amazon Macy, Athena, Redshift Spectrum, S3 Select, Inventory, Storage Class Analysis. Some of them are available in the CloudSiksha AWS course. We've discussed on storage classes and inventory and all that. I'm not too sure now whether they will ask you about Amazon Macy or Athena or any of them because they've been introduced very recently and their official guide does not carry any details about this. So I don't expect them to happen, but you never know. You may want to just quickly look at what they are. Okay, so that sort of gives you an overview of S3 and Glacier from the examination point of view. Okay,